phases of contaminants: adsorbed, dissolved, vapor, free, different types of contaminants, hydrocarbons, aliphatic, aromatic hydrocarbons, nitrogen, sulfur containing hydrocarbons, and so on, DNAPLs, LNAPLs, different kinds of DNAPLs and LNAPLs. We also looked at contaminant transport being a player in the whole thing. We do not have the time here to go through a whole course on contaminant transport or a whole section of contaminant transport, but you have to consider advective transport, diffusive transport, dispersive transport, reactions, and so on. It's a much more a course by itself, just studying contaminant transport. If you guys have any questions, if you're doing projects in the area of contaminant transport, and if you want to bounce some ideas, I'll be happy to sit down with you and talk about your particular project. Okay. Then we looked at concentrations, different this thing, some ppm to mg per meter cube conversions, a few example calculations, partitioning on different phases, and Langmuir's and Freundlich's isotherms, Henry's law, and partitioning of different phases, and so on. Okay. Any question on what we have talked about yesterday? Any questions at all on what you think I should have? I can talk more or talk in more detail, or something that was not clear. You know, if you don't ask questions, I'll ask questions. So, okay, if you do not have any other, thank you. Where we left off yesterday was here at design approach, selection and application. So when you're designing a remediation system, you have to consider a few things. One of them, you must have a good knowledge of the site itself. Okay, and I cannot stress you enough the importance of site characterization. If you work in the field, either on the client side or on the consultant side, you must make sure that there is enough budget put aside for a detailed site characterization. Okay, time and again, a poorly characterized site eventually leads to a lot higher expenses from the client side. So you may have to educate the client, if you are on the consultant side, about the value of spending a little bit more money on trying to get a good site characterization. You have to have a good site plan. You have to have an operation and maintenance problems that you need to identify. Public relations. Public relations is very important, because you suddenly start a site remediation project in the middle of a town or a city, you would find that people are inquisitive. They'll come and ask you questions, kya ho raha hai, what's going on here, why things are happening, right? And there might be odors, there might be smell, there might be noise, there might be other things. And unless you have gotten the public on your side, there might be complaints. Okay, it's best to inform the public. You have to be absolutely transparent on what you're planning to do. That this is a site, this has to be done, this is what my plan is, this is how it is. You need the public's support, otherwise they can create a lot of issues. You have to be aware of the regulations. You have to be aware of the health and safety issues, especially the workers. Okay. Sometimes the site is so badly contaminated that you cannot avoid. You cannot that any kind of an exposure of the site will affect the workers who are working on the site. Okay, and you can't afford to do that. So you may have to think of remediation techniques that are in situ, on site in situ, because you cannot take the site out. They take the soil out because of the enhanced exposure to the workers who will be handling that material. Okay, so the very fact that exposing a site to the worker might actually determine whether you are whether you're going to choose a particular remediation technique or not. You have to think about the effectiveness of the system that you're planning to do, cost, time, level of cleanup. And this is important. Last time, yesterday when we were talking about, I mentioned that about partitioning of contaminants, right? If you are doing something in one of the phases, there's a good chance the contaminant will start to move as that phase depletes of the particular contaminant. Are you with me on that? So if you, for example, if you're taking out the vapor and treating the vapor, the contaminants that are present in the liquid phase or in the solid adsorbed phase will start to move to the vapor phase, and now you will have a much higher volume than if you had just considered the vapor phase. Okay, the cost of the project will be significantly higher if you factor all that in as compared to if you don't factor it in, and that might be a problem for you. Level of cleanup. What level of cleanup do you want to achieve? So we want to go from X to what? Point 1X, or what do you want to achieve? Okay. The process itself, preparation of site specifications and site plan specifications, you have to have monitoring and a sampling plan. How are you going to sample the site? What kind of a method will you use? Will you use judgmental sample? Will you use a grid sampling? And there is different ways of sampling. You have to factor all that in. So what are the designing a remedial system? First, you have to do contaminant delineation. This is the site characterization I talked to you yesterday. You have to determine the site geology and hydrogeology. A good, this is a time when if you are not a geologist or a hydrogeologist, but you have a site to clean up, it's not a bad idea to bring in a geologist or a hydrogeologist to talk about the site. What kind of what are we talking here? How far is the groundwater table? What is the what is the geology in the subsurface of the well? Like how deep is the bedrock, right? Is it a shallow bedrock? Is it a deep bedrock? If it is the bedrock fissured? Is the bedrock cracked? Do you think that the groundwater is moving at a faster rate in a particular direction? Groundwater direction also changes with time of the year. Think of here, there is the monsoon season. In the monsoon season, you have a lot of rain. If you have a lot of rain, the groundwater is getting recharged, right? Some places the recharge is higher. If the recharge is higher, the groundwater, let's say, in a particular time of the year moves in one direction. Because of the recharge, it might start moving in another direction. Okay, and you have to be aware of that. So that's why if the site is big, bringing in a geologist, a local geologist, a local hydrogeologist who knows the geology and the hydrogeology of the neighborhood is always an asset. Okay, contaminated site, this whole area is a teamwork. Okay, by alone working on it, you may not achieve the level of success that you would achieve if you bring a team in. You should always look at the team. When I say team, not just somebody else you know or a friend of yours, it's more of a background difference. If you are a geologist or a hydrogeologist, find somebody who is an engineer, a biologist, a chemist. So get a feel of that, because every contaminant behaves differently. Their reaction to the soil and the clays and the sand and the organics is very different, as we saw yesterday, and that makes a huge difference in, because your liability and so here is how things would work. If you're working on the consultant side, which is where I think there is a significant chance, if you're working on the consultant side, the client will give you a project. Okay, what does the client want? Let me ask this question. What would a client want? Right. The client has one and only one motive. Okay, the client does not want to be bothered with your jargon. He or she on the client side will like, I want this site gone and off my books. Okay, now recently in the last couple of years in North America anyway, and what has happened is companies are expected to report their contaminated site liability on the liability side of their books. That is huge. That is a big game changer. So basically, accountants are forcing not accountants, but the regulators are forcing companies. So let's say you have a big company X, okay, doing petrochemical stuff, okay. So what does it report in its annual report? It will say I've sold so much material, I made so much money, I paid my staff, I got this. At the end of the day, this is my profit. Okay. Rarely did they report I've got a contaminated site. I've got 1,000 contaminated sites or 500 contaminated sites, from very small to gas stations and so on. Okay. They don't. But what has been happening is there is a push for these companies to report that site as a liability in currency values, so in Indian rupees, right? So that has probably not come yet here, but it's only a matter of time when companies will have to actually report that as a liability. That's a big game changer. So now suddenly you have this revenue and you have this profit. But if you bring in a whole bunch of contaminated site on the liability side of the books, it's a big problem, right? So, as I said yesterday, site cleanup is not cheap. So don't cheap out. Make sure you have enough budget to do your work properly. Okay, so with that, there will be a need to clean up most of these contaminated sites. So cleanup goals and regulatory requirements, you should identify what you want to achieve. Okay, quite often or many times it will happen that once you start the project, your client will say, okay, can you do this? Can you make sure everything is laid out properly? What do you want to achieve? Okay, from the client side, they're very clear. They want to remove the contaminated site. They want all that contamination gone and off their books, right? They don't want to be dealing with that site any more than they have to. You have to come up with remedial action plans, evaluate the different options. Quite often, multiple different remedial options are possible. You have to conduct feasibility study or pilot study, okay? Because you need to know how that particular environment, geology, whatever, right, actually works with what you have tried to come up with. For example, if you're doing solidification, if you're using cement to solidify, you need to know what ratio of cement and the contaminated soil is you can use. You can read a bunch of papers, but that's not going to tell you what you have to use on that particular site, right? And how can you cut costs? Cost is always a number one consideration in any of these, because it is considered as an overhead. It's not something that's going to generate any revenue for the clients, so they will try to squeeze the cost. But and maybe rightfully so. But you have to be aware of the fact that there are cost implications of it. Then come up. What are the design objectives, design parameters, site survey, preliminary equipment requirement, then come up with conceptual design, process diagrams, control diagrams, fuel operation and maintenance manual, system. It is an operation, okay? If you want to look at an equivalent in the rest of the civil engineering side, let's say you have in structural engineering, you're building a building, right? You have to bring the equipment on site. You have to have places to store the equipment. You have to have workers coming in, trucks moving in, all that logistics has to be worked out. This is also the same thing. You still need to have the systems, the equipment, how to operate it safely, what maintenance is required in the equipment, and so on. But on top of that, one of the things here which is different is that you need to probably do a pilot test most times. Okay, to pilot, because Without doing a pilot, you might get blindsided because the geology might be different from where you had worked on last time. Okay, this is known as, the next part is what is known as a risk-based corrective action, or Rebecca as it's called. So normally what is taken as is known as a tiered approach. A tiered approach is tier 1, tier 2. Sometimes it's tier 1, tier 2, tier 3. Americans use a tier 1, tier 2, tier 3 process. The Canadians, we use tier 1 and tier 2, and then an exposure control. I'll differentiate that in a bit here. So tier 1 is basically a guideline, generic. Okay, so I'm sure if you look at, they will say, okay, you need the soil to be, if it is an industrial site, the concentration should be maximum of so and so. If it is a commercial site, maximum so and so. If it's a residential site, that's why it's like a lookup table, okay, that the regulator has put down. So you can go and Google and find out that, for example, the number that comes to my mind, lead for a industrial site, according to the CCME guidelines, is about 140 milligrams per kilogram. Okay, so that's so it's basically looking up at a table and saying, okay, what do I have at hand? Do I have a residential site, a commercial site, or industrial site? Okay, so which of these criteria will be higher generally? Where would the regulators be most conservative? Industrial, the regulators are most conservative? Which of these would be the regulators be most conservative? By conservative, I means most strict. Industrial, commercial, or residential? Residential, right? So the number for residential will be the lowest, right? Commercial is usually similar to residential. Sometimes it's even, not sometimes, many times you'll find it's the same number as residential. Because commercial is like, this is a commercial place. Schools are commercial, malls, all that, right? But commerce activities, institutions lie in that as well. But the thing is, when you do a risk assessment, because here is one thing, let me tell you, most of this is driven by risk. Okay, if your site has no risk, is there a need to remediate it? Right? Everything is governed by risk. So who is your most susceptible client in a residential site? Whom would you consider as the most, as the one that I should prevent the most, or most susceptible, I should say? Toddlers, children, right? Because so if you have a house, then the kid is living there, right? So it is. So on the commercial side as well, the same thing applies. Mall, children go to mall. There are daycares where children go and stay for 8 hours a day, right? So because the target is the same for commercial or industrial or residential, okay, the numbers are also same. The one needs to meet. On the industrial side, the target is an adult. You don't expect a child to show up on an industrial site, or definitely not be there. Okay, so the chances, so basically the child is not a target in an industrial site. If it's a classified industrial site, you're not expecting a child there, should not be there, because you have machinery moving, you have equipment moving, you need hard hats, you need steel-toed boots. It's a place of operation where it's not you can't have a child running around. So the target is a full-grown adults, because it's a bigger target. You find that it is the numbers are higher, more flexible. So you need to understand which one are we talking about, industrial, commercial, or residential. And the lookup table, basically it's very straightforward. If you're on the client side and if you're remediating a contaminated site, and if you want to do, okay, I'm going to do a tier 1 approach, you go and look at the tier 1, Google the find out what is applicable for your place. Now this is something you need to find out, what that site, who regulates that site. By that I mean, for example, in here, is that site regulated by the government of India or the central government? Is that site regulated by the state government? Is that site regulated by the local municipality? Okay, who, under what jurisdiction it falls? All right. So whose jurisdiction? Accordingly, the numbers might be different. They may not be greatly different, but they might be different. You need to know what you're trying to meet here. Okay. So, but it's very straightforward. If you have a little bit of experience working in a particular jurisdiction, tier 1 is finding out the criteria is easier, much easier. Okay. Then we come to what is known as a tier 2. Now tier 2 is this is site specific targets depending on the site information. Okay. So if you, for example, if you have a site, so tier 1 numbers are usually quite conservative. For example, they will think, let's say the city of Allahabad, they'll have, we'll have to look at people living and all that, right? But let's say you have a site 50 kilometers outside the city of Allahabad. Okay, and there's nobody there. Nobody lives there. It was some kind of a refinery site or whatever, and it was there. The site is reasonably secluded. You have put a nice fence around it, that even if somebody just happens to go there, they can see the fence and not jump into the site, right? Let's say you have that. Now, should the two sites be treated equal? No, right? So that's how you will make a case to the regulator that, look, I'm going to do, I'd like to go with a tier 2 for this one. Okay, and site specific targets might be determined based on that. The chances of a toddler coming there on that is not there at all. There's no one around for another 25 kilometers. Nobody's come there, and if somebody does show up, I've got this nice fence. Nobody's going to cut across the fence. All that, I've got a guard or whatever to make sure that nobody comes in, and so you can get by with what is known as a tier 2. Tier 3 is much more site specific conditions. So now let's say you have you might feel that the site is quite does not pose a lot of risk. Okay, you might choose to do a risk assessment. You can tell if the regulator is not agreeing to your numbers on saying, okay, you need to do this, and you think that you don't need to do it because if it's a site poses low risk, you can conduct a site specific risk assessment. Okay, which is basically, in that situation, you should palm out the site to somebody who does risk assessment. Okay, if you are a client, so do you understand what I'm saying as a client? Whom am I calling a client here? The company which produces. Let's say you have the company that is producing the waste or has produced the waste. There is the consultant which is trying to manage the thing. Okay, and then there is the regulator which wants to make sure the site is cleaned up. If you happen to be on the company side of things, okay, you might say, okay, I'm going to do a full-blown risk assessment. Okay, And what you do at that time is you hire somebody to do the risk assessment. Somebody who does risk assessment as for a living. Okay? Do you understand what I'm saying? There is a big difference between somebody doing risk assessment on the side and somebody who does risk assessment for a living. Okay? Because they have a much better feel for how to go about doing it. It is a complicated process. It's not an easy process. You have two things. We're fighting against two things here. One is that the risk assessment itself, and as you will see in this course, you will see that there is a level of complication that will make it challengeable, because your data that you're assuming for the risk assessment might get challenged. You want to make sure that you don't have that. That's why you need to hire the person who does risk assessment for a living, is a very respectable person or respectable company, and then you get the risk assessment done. It costs you money. Hopefully, if your risk assessment can shows that there is not a whole lot of risk, you can ship it. You can give the report to the consultant, to the client, to the regulator, and the regulator might buy into the idea that the site does not pose any risk or poses minimal risk, and in that case, you can get by with less work. But the risk assessment itself is an expensive part that somebody has to bear. Okay. So this is so that's the more generic thing that I talked about. This is from my jurisdiction. The process of, and this is similar across board. So I thought I'll use that as an example. So tier 1 basically protects the site that is most sensitive. So it is basically looking at lookup tables. Tier 2 allows for certain modifications to tier 1 containing site specific information. Sometimes a tier 2 also becomes very conservative. Okay. For example, if your site has something unique, right? Let's say your site has got a very unique, sensitive, population of any particular ecosystem. Okay. If your site has something very unique about it, the regulator might actually want you to do site-specific numbers which are more conservative than what your tier 1 would say. You understand what I'm saying? Right? Just because you are going from tier 1 to tier 2 does not mean the numbers will go up. That means what it means is the numbers will change. Okay? If you happen to have a site in which there is a very sensitive ecosystem that's present, okay, maybe certain specific rare animals or rare kinds of whatever, snails or whatever, right? Suddenly you will find that the regulators are much more vigilant and aware of and also what kind of numbers you meet than what the tier 1 is, which is applicable for the entire jurisdiction, right? There's also something known as an exposure control or risk management. Risk management is basically you can try and manage through barriers or site-specific risk assessment. So you might come back to the regulator and say, look, I'm going to manage the site. Basically, I'm going to put a barrier around the site. I'm going to put a fence. I'm going to put a land cover on the top. I'm going to make sure nobody goes there. I've got to put a guard on the ground, whatever, right? So I'm going to monitor it so it does not spread, and that's acceptable, and they will be willing to buy into it. You might get yourself 5 years, 10 years time. Okay, so that's the third, what is known as an exposure control or risk management. Now, that will not help you take the system out of your books. It still remains in your thing. Every year you'll have to report to the regulator what happened, how it happened, and all that. But the data and all that, but it does help you, give you time, and you might be willing to buy time for a number of reasons. One is you are pushing your current expense into the future expense, right? You might be waiting for a technology to develop. There is no, let's say there is no known technology to treat at the moment. So you can say, look, I'll come back and visit it in 5 years, 10 years, 15 years. By that time, some other technology might come. Some technology might come. So, for a variety of reasons, you can do exposure management or risk management, and the regulators are usually quite cool about it. Okay. I talked about this in the previous slide when I said the tier 1 and tier 2. While tier 1 is specific lookup tables, tier 2 can occasionally be more restrictive than tier 1. What are the land use areas that we should look at? Natural areas, agricultural land, and residential and parkland. The numbers would be different for each of them. So if it is a natural area, forested areas and so on is natural land, right? So they have a different, let's say, number criteria than agricultural land. Okay, agricultural land is used for growing crops and livestock and even for human residence. Then there is residential and parkland. Parkland is basically parks within this. These are urban parks, not the parks in the forest, right? So these are and they have residential or recreational activity. Commercial land use, where public, including children, have unrestricted access. Industrial land use, for manufacture and construction of goods, public access is restricted and children are not permitted continuous access. So these are the different land uses. Now, based on the land use, you will have a different number, right? As we can tell, if the land use is just forest, then it will not be the same number as you have, let's say, for agricultural or residential, right? And I was talking earlier that the industrial will have to be different from commercial and residential, because in industrial you don't expect children to be there for prolonged periods of time. So on the water side of things, there are different categories as well. There is drinking water or potable water. There is aquatic water, which is water in rivers and lakes. There is livestock and wildlife watering, or water which is used for livestock, and irrigation water. Okay, water used for irrigation of crops. All right. So there are different criteria, and you have to also look. So if your contaminated site is hydraulically connected with the groundwater well, which happens to be the drinking water source for some farmers downstream, what are you going to do? Which criteria would you apply if your contaminated site is hydraulically connected to a groundwater source downstream, which is used for the farmer to drink water and to serve his family and serve his livestock? And you have to meet the potable water criteria, right? Okay. But what will you do if that situation happens and you are trying to risk manage the site? What will you do if you are trying to risk manage the site if it is in that situation? Do you get my question? Huh? Find what? No. So what is risk managing a site? What do you mean? What do I mean by risk managing the site? Huh? So risk managing a site is I'm going to minimize the risk. So I put barriers, I put export. How will you risk manage a site in which the downstream end there is what is the first thing you will do? No. What is the first thing you will do if you find out that a site is contaminated, but it is the water that is going through this contaminated site is actually serving as a drinking water? Right? Inform the people. Right? That's the first thing. Right? Absolutely. Absolutely right. That's exactly what you have to do. Very first thing to do is to tell those people who are drinking that water to stop drinking. First thing is, of course, to inform the regulators, but inform those people who are taking that water and provide them with an alternate source of water while you think what to do. Because you cannot expect them to live without water or tell them, you can't do that. You have to actually provide them with an alternate source of water, either bottled water or trucked water or whatever. That while you have got yourself some breathing space as to how you are going to manage it. Okay? So that's the very first thing you have to do. Because if that guy is not told in time and one of his family members or somebody becomes sick, now you have exposed yourself to a lawsuit and a whole series of expenses, as well as the moral issue of somebody, some event that you could have avoided from happening. Okay? So, but once you do that, your next stage is to find out how can I prevent the water from leaving my site. Okay? Obviously, the person is not living on your site, is living downstream of your site. You have to then find ways of taking, because once the water leaves your site, you have a problem. Within your site, you still can manage it, somehow putting barriers, whatever, pump it out, do something. But once it goes into somebody else's land, once it has left your property boundary, okay, you have lost control over it. I've seen many clients ask me this question: when is it going to hit my property line? How long? And this is something for those of you who are doing contaminant transport should think about. Because one of the things that really bothers a client, a producer or somebody who has the contaminant site is, when is it going to hit my property line? How much time do I have? Do I have 5 years? Do I have 10 years? Do I have 2 years? Or is it already past my property line? If it is already past the property line, or you've got only a few months left, that's a very different scenario from a remediation where you have to act on it right now, as opposed to, let's say, you've got 5 years time. Okay, so okay, the tier 1 guidelines are basically how the guidelines have been developed. Well, these are risk-based guidelines. There is substance toxicity. It should be present in soil or groundwater. There is presence of receptor. So the whole area of and I'm going to move on here because I can talk some of this when we talk about risk assessment. So these are the steps in developing the tier 1 guidelines. Okay, these are the, so when you're looking at a table and say, okay, lead is 140 milligrams per kilogram, how did they come up with that number? That's how this is. So you really don't need to know as much about it, as it's good to know where it comes from. So somebody says, okay, how is it 140? Why is it not 100? Why is it not 300? You can see the equations that's at the back and how they came up with. So idea is this: they want to make sure that there is a receptor, that there is a pathway, and so on. So we can come back and talk about some of this when we talk more about risk assessment. So identification of appropriate protection endpoints for each pathway. Okay. So in risk, so let me talk a little bit about risk, because I keep talking about risk assessment without actually getting too much into it. So let's probably talk about it. So what what is risk? What is your understanding of the word risk? Louder, what is it? Harmful to environment and human health. Right? What's your name again? Pawan. So Pawan's definition. And human health, I'll call it HH, okay? Anyone else? Something which is dangerous, right? Okay, what's her name? Jayashri. Keshri. Am I right spelling wise, or I've killed it? Oh, Kesni. SHNI. Okay, apologies. What did you say at the back there? That's not risk. I don't even want to write that down. Come on. Something is gained and lost. I lost my cell phone. That's not risk. Is that what you're talking? No. What is risk? Think about it. That is some parameter that defines how much you are getting affected. I think we are going too far from the definition. So what is it that embodies the word risk? Okay. So let's look at an example. So riding in a car, is it risky or not risky? How would you perceive it? It's risky. And riding and what is the risk about? Accident. So okay, so basically risk has two things in it. Okay, first thing is probability of an event happening. The reason you call it risky is because the chance of running into an accident is higher once you sit behind the wheel of a car, okay, compared to not going anywhere. I'm not comparing it to like walking across the street or anything. Compared to not going anywhere, the probability of getting into an accident when you sit behind the wheel of a car and drive is higher. So that is the probability of harm. Okay, and what is the other thing that causes risk? The consequence. What happens, right? So yes, you might get into an accident. It might lead to a death. It might lead to dismemberment. Maybe part of the body is lost. It might just lead to nothing in terms of the consequence. So risk, by definition, is the product of probability and consequence. Okay, think of an aircraft. Is it risky to ride in an aircraft? How many of you think it's risky to ride in an aircraft? Come on, it's not a trick question. All right, all of you think, right? How many of you think it is riskier to ride in an aircraft than to ride in a car? You think it's riskier to ride in an aircraft than ride in a car? So many of you think that is riskier. But we all know one thing, I'll tell you, subconsciously you know that aircrafts are one of the safest mode of transport. So probability of something happening is much lower. Just by the fact there are tens of thousands of aircrafts all the time in the air. Okay, but the consequence of something happening, if something happens, is a lot higher than the car, right? And there are lots of accidents. If you look at, if you just happen to stop for a half a day, you will notice that there are probably a dozen accidents that has happened even in this city. Small accidents, knick-knacks, and somebody hitting somebody, or fender benders as they call it, right? But not something. So there is a but you see, when you compare with aircraft with the car, one has a much higher consequence but very low probability of event. In the other case, the consequence is not that severe, but the probability of the event is high. So risk is basically the product of probability and consequence. Okay, that is risk. Okay. Okay. So you mentioned, I'm going to go back and look at this one again. You mentioned something that is dangerous. So that is general definition of risk we talked about. That has nothing to do with environmental or anything. We gave examples which are outside the area of environmental engineering. When you said that it is something is dangerous, okay, for risk to manifest itself, you need to have a danger, right? Probability of an event. The event has to be an adverse event, not just an event, right? So let me give an example. Let's look at an example. Let's say we all came into this new classroom, right? This is the first time I'm here, the first time that you are here for many of you. Let's say in the corner of this room, there is this drum filled with a very hazardous chemical. Okay? Let's say there is this drum that is filled with really hazardous chemical. Okay? And our hosts tell us, don't worry, it is all sealed. Okay? Now, the fact that the drum is there filled with a chemical is a hazard. It is not a risk at that stage. If it remains sealed and there is no leakage, there is no risk. Keep that in mind. Look at my assumption. Assumption, it remains sealed, no leakage, nothing happens to it. The risk is, there's no risk, because there is no pathway, and because there is no pathway, there is no consequence, right? You see, the consequence requires something to be there, somebody to be there, right? So in the risk that we understand in environmental, we need, for risk, we need three things. We need a source, which is our drum in the corner of the room, right? If the drum is fully sealed, completely sealed, and remains that way, there's no pathway. Okay? The second thing we need is a path. Something leaks from the drum, it needs to make its way to us. Okay? So the second is a pathway. Okay? So the fact that we are all here, we can smell it. It might volatilize, be a part of this room. It gets into our lungs, becomes a part of our system. It might get into the water somewhere down, and we might have to drink it. There is a pathway. Okay? If there is no pathway, if you take this one out, what happens to risk? Decreases substantially. And the third thing, what is the third thing we need? The third thing we need, receptor. Okay, so we come into this room, our host tells, that's a drum, don't worry about it, it's there, it's sealed. And collectively we decide, we don't want to hold this class here. We go to the next building. Okay, whether the drum leaks or the drum remains sealed, whether there is a pathway or there is no pathway, the receptors have left the building. Okay, there is no risk again, right? So for risk to manifest itself, you need these three things. You need a source, you need a pathway, and you need a receptor to be present. For a residential site, your receptor is a toddler. And commercial sites. For an industrial site, your receptor is a full-grown adult. Okay? And the pathway you need to think about are, what are the pathways? Again, look at the drum. What are the pathways? Inhalation, dermal, right? It can come and become part of the air, and we can breathe in, or it can be it can sit on my skin, slowly get absorbed by the skin. If it gets into the groundwater, it can become a part of the water, in which case I might be drinking the water, I might be showering in that water, and you are in the shower, you take an average shower of, let's say, somewhere between 5 and 15 minutes, and you will be exposed to the warm, the temperature will volatilize it and will become a part of that room, and now you're going to take it in through the lungs. It will also go in through the skin. You might even ingest it, because when you're taking a shower, the water goes into your mouth. All that has to be factored in. Okay? And then you find out how much of it accumulates in your system through each of these pathways. And that's the amount you take it in. Okay? That's how we do a risk assessment of, that's what I said, if you actually have to do a tier 3 or a site specific risk assessment, it's best to get somebody who knows what he's doing or she's doing before you embark on that. Okay? So that's how they've developed the tier 1 guidelines. Protection of human health. You have to look at things like dermal contact, inhalation of soil particles. Okay, so you have to also think about the risk to the workers. You take out a site, now it's all over the place, right? You know, it is buried and all that, but now you have taken it out, it's in the air. You'll have inhalation of soil particles, and then drinking water from showering, bathing, inhalation, volatiles being released into the soil, groundwater migrating into living and workspaces. Of these three, which is the one that has the most amount of effect? Inhalation, ingestion, and dermal. Which of those three you think? Which of the has the most profound effect? Inhalation. Why? Right. Because our lungs are designed to take the air in from the atmosphere into the bloodstream, and along with that, these things get pulled in. Ingestion is the second, because it's still in the system. It might get absorbed. If you're lucky, it might just get excreted out. Okay. The third one is dermal. The skin is a protective organ. It's designed to give protection. So of those three, that's the one that would have the least. But having said that, if you have too much skin exposure, you will have rashes and all that, and eventually absorption and impact, right? Off-site migration by wind or water, transport from adjacent site to more sensitive land use areas. That's another thing you have to think of. Okay. So let's say you dig out your site, and now you got all your contaminated soil around, and you have wind blowing it to another park or somebody else's land or something that is much more sensitive. right? The human health protection endpoints. Now, this is important to, again, on the risk side, there are two categories, the non-carcinogens and the carcinogens, so the cancer-causing and the not cancer-causing. So level of exposure of a chemical that does not cause cancer, we define what is known as a tolerable daily intake, or TDI. Okay, and I can give some examples of how a TDI is done. So basically, let me give you an example from the water side of things, because it's a lot simpler. Okay, so let's say you have, remember yesterday we were having this little game playing where he said you work for a regulatory body, and your boss comes and tells you that, look, we have this problem, I'm hearing about chromium, we need to come up with a number. Okay, so let's say we continue along that thought. So same thing, you go to literature, you find out what toxicologists are saying with regards to the no observed adverse effect level, the low observed adverse effect level, and so on, right? And you find out what the adverse effects are. You take all of those, you take all those low observed adverse effect and all that, right? Then you have, and typically those results belong to mice or rats or whatever they have studied. Okay, then you use an uncertainty factor. The uncertainty factor will be factors like interspecies variation, because the person has studied in rats, I'm moving to humans, there is an uncertainty how humans will react. Then there is availability of data. How much data you guys studied in 5 rats or 55 rats? Okay, how good the study was in your opinion. Intraspecies variation, for example, us as a population, there are sensitive subpopulations within us, right? So all that, you take it and put it together, what is known as an uncertainty factor. Remember, the LOL or the null that they are talking is here, right? Very high number, because it probably developed tumor in rats or whatever, whereas you want a number that doesn't affect anybody at any time. Okay, so you divide all that and you come up with what is known as the tolerable daily intake. Okay, and from that tolerable daily intake, you come up with what is known as the maximum acceptable concentration. Okay, that's only for non-carcinogens. If you have a cancer-causing agent or a carcinogen, things are different. Okay, the level of exposure for a carcinogen must not exceed a lifetime cancer risk of 1 in 10 to the power minus 5. Okay, between 1 in 10 to the power minus 5 and 1 in 10 to the power minus 6. 1 in 10 to the power minus 5 means 1 in 100,000. Okay, so the chances of developing cancer by exposure to that particular chemical over a lifetime of exposure to that, for a 70 kilogram adult, should not be higher than 1 in 100,000. Are you with me on that? The concept. So the chance of somebody developing cancer, if they have been exposed to that chemical over a lifetime, should not be more than 1 in 100,000. So if 100,000 people have been exposed to that particular chemical over a lifetime, not more than 1 should develop cancer. That's what it means. Okay, that's a reasonably low risk. Okay, considering all factors. We cannot have zero risk. Can we have zero risk? Why not? Practically not possible, right? So you cannot have zero. You have to have a little bit of risk. The very fact that we are alive is there is a certain amount of risk, right? So somewhere between 1 in 100,000 and 1 in a million is what is known as a background risk, which means you can do whatever you want, you cannot decrease that number. You can stay as a hermit somewhere, still you will have to eventually, there's some very low risk, right? So that's the concept. Ecological protection of ecological receptors expected on site, preservation of an appropriate level of ecological function of a site in its ecosystem. I'm going to move here. Principles of contaminant management. You have to identify the sources. You must remove the sources, and then delineation is what is the horizontal and vertical extent, and then manage the contaminants in the subsurface and on the site. So tier 2, modify tier 1 based on exclusion of exposure pathways and receptors, adjust tier 1 guidelines using site specific values, and when basically they allow you to modify your tier 1 with site specific information. So in tier 1 it's always toddlers, right? Because that's how the tier 1 number was derived for a residential commercial site, right? But if you have a site which is out there somewhere, there is no chance of any toddler coming there at all. You have taken adequate precaution to prevent anybody coming there at all. Forget about toddlers, anybody ever coming there. You have put a cover on the top, you've done whatever you can do. Well, then you can justify that that particular receptor is not present. You look at for a higher level receptor, and then therefore you can modify the tier 1 guideline. That's your tier 2. Okay, so the protection level for the tier 2 and the protection level for tier 1 have to be the same. This is the one thing that the regulators look for. By the way, who is the regulatory body on the environmental side here? CPCC, Central Pollution Control Board. That's the central. What about the local or state pollution control board? So as a part of your homework today, look for what kind of guidelines do they have. Look for the Central Pollution Control Board, CPCC. What do they take? There are 3 globally. There is the US EPA, which has a set of things, right? And then there is the World Health. Okay, those are the 2 major ones. The Europeans have one. Others mostly take these and adapt it. Some just adopt it, and some adapt it, change it based on their own site conditions. It is a good exercise for you to actually look what kind of numbers they are. Maybe they've adopted World Health numbers. Huh? Right. Yeah, right, because it's in the absence of anything, just take some number and have it, right? So just find out what they have done. It's good to know. But when you do a tier 2 risk assessment, one thing to keep in mind, it should use stable and measurable parameters. The parameters that can change, such as there is a building on site. Okay, you can say, oh, you know what, my risk is low because there is this building on site. If there's a building on site, of course, but the building can move, right? You know, 6 months later, somebody's actually trashed the building's gone, the site is exposed, right? So you cannot have something that is, it has to be very stable. That's what they mean. And this is all conditions that trigger tier 2, and I will just move very quickly on this because these are may not have that much relevance. Sensitive receptors present not accounted for in tier 1, groundwater flow to stagnant water bodies, soil and groundwater present within 10 meters of surface water body, and so on and so forth. So okay, I was talking about risk assessment, which is for the risk assessment, these are the 4 steps you need to follow. First is what is known as a problem formulation. Okay, so let's come back to that example of having a drum in the corner of the room. Okay, that's a simple example. That's the problem. That's the problem formulation, the very fact that it is present and what is the risk it is posing to everybody. Okay, then you have to do a toxicity and hazard assessment. Okay, so what is contained in that drum, right? So what is the toxicity of the material that's present in the drum? The very fact that the drum is there and it is something that is harmful gives it a hazard. You have to do a hazard assessment. Okay, if the drum is empty, it's just a drum, then there's no hazard, right? If the drum, so there's no hazard, there's nothing after that. There can be, but the fact that we are here and the fact that the drum is open, there is a pathway and there is a receptor, but there's no hazard. Okay, you have to do an exposure assessment. Exposure assessment being like what are the different ways it gets into us. Like I, for example, am a visitor. I'm here for 3 days, 5 days, a certain number of hours, and I leave. You, the people who are local, might be exposed, you may be attending classes here for maybe 4 years in this particular room, right? Or in this building. Okay, there might be people living in that building. Those kind of things. Then you have, those are exposure durations, right? How much is the duration? So coming back to this example of somebody farmer drinking groundwater contaminated with the from a well, you'll have to find out, okay, how long is that person, and you have to take a lifetime in that situation, right? So that's your exposure assessment, and then eventually you combine all of them to come up with what is risk, and that number has to be less than 1 in 100,000 for cancer causing agents. Oh, yeah. This is exposure control or risk management, basically ensuring short-term remediation levels in excess of guidelines do not rise to unexpected risks. You basically control the risk of a contaminated site while you think about what you want to do. And when you talk about an exposure control, you have 2 things to think about: what is known as an administrative control and an engineered control. An administrative control is things like having a barbed fence, a barbed wire fence, making sure that nobody accesses it. You can do land use modification. You can apply to the regulator and say, this was an old commercial site, but activities there is now this. Can we classify it as an industrial site? That way, you will not have any kids coming on that site. Okay. Groundwater reuse restriction. We talked about that farmer where you'll supply with an alternate source of water. Building placement restrictions. You cannot. Those are the administrative controls. And the engineered controls are like putting a soil cover on top, a permeable barrier, point of use treatment where you say, okay, I'm going to filter the water and so on. Okay, so that brings me to the end of this one here. Okay. Okay. So this is your second set of notes. you have a slightly modified version of it. The pictures are missing, as you would see, but the pictures are basically for illustration purposes. They are not serving any other. It's not a graph that you can read and take numbers off or anything. It's just to illustrate what we are talking here. So you don't need to have those pictures anyway. So contaminated sites are areas of land that contain chemical substances that pose or are likely to pose a hazard to human health or the environment that exceeds the level set out in policies and regulations. Contamination is most often the result of past activities that have environmental consequences that were not understood at the time. This is taken from the federal contaminated site and so on. This is another site that is fairly contaminated with lots of other issues like PCBs and so on, that you can see the picture here. So there are lots of these contaminated sites that exist. The Superfund site, this whole idea of this of trying to. So here is a question for you. When do you think this environmental this awareness started? You know, everything needs a catalyst. Everything needs something to, you know, you need something to happen, right? Huh? World War? No, that's right. The London smog in the 1950s, where I think a few thousand people died. That's for the air pollution, where they started cleaning up there. There was a book by, have you heard that book called Silent Spring? The author is Rachel Carson. She wrote a book called Silent Spring in 1962. And that book, she painted a very bleak picture of the world. You know, with thankfully, her prediction has not come true. But that's the one that actually got people to think that of this so-called contaminated environments and the health impacts and so on. Okay, if you get a chance, just read that book. It's called The Silent Spring by Rachel Carson, and she has since then written another book called Silent Spring Revisited or something. So she talks about the spring being silent, right? No birds, nothing. So it's a good read in that sense. So environmental assessment and remediation. There are 4 phases to an environmental site assessment and remediation. Okay, so if you have a client and the client comes and says that we have this contaminated site, or pretty much we don't know whether we have a contaminated site because you are at that stage, how would you go about doing a site assessment? Okay, what you're going to see from here on is a structured approach to identifying contaminated site assessment. Okay, so the first one is known as the phase 1. So it's 4 phases. In some places it's 3, in some places it's 4. Okay, in the US they have this 4 phase. In Canada we have a 3 phase. The phase 3 and phase 4 are merged in one. Phase 1 and phase 2 still remain distinct. The phase 1 is a non-intrusive investigation, which means you are not going to collect samples. Okay, you are not going to analyze anything. You're just going to talk and find out what has been going on. Okay. Phase 2 is where you'll do intrusive investigation. Okay. Phase 3 is remedial planning, and phase 4 is then implementation. Okay. Um, for an environmental site assessment, we'll come back to those different phases in a bit here. For environmental site assessment, there are several standards and guidelines and guidance documents that are available for this. Okay, standards and guidelines vary across provinces, states, and territories. There are two that I have quoted here. These are the standard associations. There is the World Health, there is the US EPA, there is the ASTM has also established procedures to make site assessment process consistent. Because if you do a site assessment and I do a site assessment, ultimately the objective, we both should come to the same conclusion. So there has to be some consistency of process, and this is what we're going to talk about in a bit here. Did you notice one of the things she said in the video was we try and get the money from the person who polluted? That is known as the polluter pay principle. Okay, that has been adopted pretty much globally, that if you are a polluter, you must pay, because otherwise the government has to pay, right? So this is a brownfield amendment in 2002 to clarify what is a liability protection. This is an all appropriate inquiries rule in 2005. Sorry, what did I do here? Okay. That a person may purchase a property with full knowledge of his contamination without assuming liability. Okay, so do you follow what I'm saying? So here is what happened. Once the Superfund thing came around, once people started realizing that there might be contamination on this ground, okay, nobody wanted to buy land, because you don't know, because the cost of the remediation is much more than the cost of the land itself eventually. So the whole commercial real estate transaction kind of came to a halt, because you don't know what's below it, and you will be stuck with the liability to clean it up. Okay, let's say you operated a refinery. I cleaned up my stuff in the top, and then I sell it to you at a slight discount, and now you are holding this liability, right? So in order to prevent that, in order to address that, they came up that a person may purchase a property with knowledge of his contamination without assuming the liability. Okay, so you can buy the property knowing that I contaminated it and I continue to hold the liability of the land. Okay, so walk with me on this. That's that. In order to get the real estate transaction going, then there is this. So these are some of the acts that came out of that Superfund. Superfund, basically this whole thing created the Superfund, the CERCLA Act as it's called, Comprehensive Environmental Response Compensation and Liabilities Act. Any element, substance, compound or mixture including disease causing agents which after release into the environment and exposure, ingestion, inhalation or assimilation into any organism either directly from the environment or indirectly by ingestion through food chains will or may reasonably be anticipated to cause death, disease, malfunction or physical deformations in such organisms or their offsprings. So they define what are known as 5 responsible parties or PRPs for cleanup, because remember, you have to have the polluter pay. Somebody has to pay for this, otherwise the government has to pick up the tab. So number 1 is current owners and operators. If you own the land and you are polluting it, you pay for it. Previous owners and operators which are present at the time of contamination. Okay, so I happen to own the land, I sell it to you, you haven't done anything, but so the liability is still mine. So even if I've sold the land to you, I have to still hold the liability. Intervening owners, somebody is there in the meantime, okay, in the middle. Hazardous waste generators who are liable for disposal in the property. So let's say I operated the site, but there is a hazardous waste company that I had actually farmed out that disposed something on the site, right? Or persons who accepted hazardous substances for transport to facilities that led to release. This is the 5 categories of what are known as potentially responsible parties. Okay. this is a very litigious field. This is, if you happen to be on this side where you have bought something, or you have been involved in this thing, that is, every party has their own consultant, every party has their own legal team and all. It becomes very, very contentious. There are some terminologies that are used, so you have to be aware of the legal implications of some of this. The terminologies that we use: innocent landowner buys the property, and despite conducting all appropriate investigation, does not know about environmental conditions. So you conduct something, you do a subsurface this thing, you find out, do some monitoring, but you still are not able to detect anything. That's what is known as an innocent landowner. You have done your due diligence, but you're not able to detect. Bona fide prospective purchaser buys a property after conducting AAI and knowing environmental conditions on site. And the third one is adjacent property or contiguous property owners that may be impacted. The liability is strict, joint, several, or retroactive. Strict liability, strict is liability party may not be at fault. Joint and several, liability is shared, and retroactive means going back in time. So the seller has an obligation to disclose hazardous waste contamination. So if I'm selling my property to you, I have an obligation, a legal obligation, to tell you what has happened on that site. Intervening landowners have a legal liability if they fail to disclose known or unknown conditions when selling the property. The buyer may purchase, but the seller may still hold the liability. So I might say, okay, here is the land you own. You start doing something. If there's any issue, I will come back and backstop it. Okay, I will continue to hold liability. Buyer may indemnify the seller against future environmental claims. We may have an agreement where I know it is contaminated, but I'm selling it to you, let's say, at 1/10 the price of the land. But you now hold the liability, right? So I'll say, okay, you know what, I'll give it to you at just a dirt cheap price, but then you hold the liability. And if contamination are found which were not known at a time of sale, the seller is still liable. So if I sell it to you and you have done your due diligence, still not found everything, and come back and say, oh, in 5 years time you find, okay, there is this thing seeping out of the ground somewhere, then and I still hold that liability. There's some other ideas. So a buyer might use an innocent landowner defense if he has conducted an environmental site assessment prior to purchase and found no contamination. They must follow good customary practice. Okay. The other thing that has happened is lenders. So normally you don't buy anything without having a bank mortgage it or somebody, right? Somebody putting the money for it. They also require environmental site assessment. Okay, a lender, if you have a bank providing the money for you, they don't want to be holding a contaminated site at a very low price, right? So they might actually want an environmental site assessment. Brokers or realtors also have a professional liability to inspect and disclose. The other thing is, individual shareholders, if found engaging in illegal activities, cannot hide behind a corporation structure. They cannot say, oh, company did it. If I have done something, being a director of a company, I have to be personally be liable, not hide behind. So, okay, so are we all clear with regards to some of the legal aspects of it? So here is in a nutshell what the legal aspect is. There is a buyer and then there is a seller, right, in transaction. So and there is a banker which will provide the mortgage. The buyer has an obligation to tell the seller what the problems are on that site. The seller, The seller has an obligation to tell the buyer what the contamination is. If a contaminant is found in the site after the fact, the seller still holds the liability. So you can't just because we signed on the deal and I managed to convince you to buy it at less than the full premium price, doesn't mean I have actually passed on the liability to you. The liability still can be mine, provided you have not done something that aggravates the situation, in which case it's joint liability. Okay? And individual shareholders are, if found engaging in any illegal activities, can be personally liable. Okay, that's as far as we need to know. But we do understand that it's a very legal wise, the legality of it is quite complex. Okay. So phase 1 site assessment. Okay, there are 4 components to a phase 1 site assessment. Remember, this is the non-intrusive one, right? So you have to conduct. So this is where you don't actually conduct any tests. You want to find out what is the problem, right? So there is 4 components you have to see. One is a records review, site reconnaissance or walking around the site, interviews, and evaluation and reporting. Okay. So what's a records review? The records review is to help recognize the environmental condition associated to a property. The review not only the records pertaining to a site, but also of adjacent sites. Okay, because it may happen that the guy next door might be doing something that's created a problem for your client. There is an approximate minimum search distance which can be adjusted based on density of population, distance, and so on. You are not going to go the next guy and the next guy. How far will you go? So there is an approximate. You probably do the next adjacent site, and that's about it. If there are gaps in information, the environmental professional should make an attempt to compensate for mistakes and deficiencies. So here is what you will do. You will look at the records not only of the site but adjacent sites, nearby sites. Compensation for mistakes if something is, you're going back in time. You're going back 30, 40, 50 years, right? People used to handwrite stuff. You might have little tables that are handwritten. Whether it is 3.9 or 39, who knows, right? The dot is kind of erased out. If you think that there's a mistake in the entry or mistake because of that, you have to make a good judgment call. That's what it means. You have to make a good judgment call and correct it. Information should be reviewed based on standard sources. So publicly available information, things like libraries, things like wherever the authorities that are storing that information, right? You have to also think about. Remember, this can become a lifetime project, right? You get a site, nobody knows, there's not data. You can spend 2 years doing a phase 1. Okay, so that's one thing that one needs to avoid in this. You want to make sure it is doable and the data is obtainable within a reasonable period of time, which is roughly 20 days. Okay, all right. You guys look tired. Do you need a break? What? The answer is no? Okay, let's take a break then, because I see you guys are. Okay, let's take a break. We'll come back in a few minutes, okay?